All right, so good afternoon, everyone. This is day 4 p.m. For day 4 a.m., we went over LangGraph and agents and how to build a system using LangChain and LangGraph agents and using a hybrid of the two. Today, or this afternoon, we're going to be getting into monitoring using LangSmith. So we have one lesson, one lab, one challenge, and then our TLOs and ELOs. So today you'll learn to implement observability in your LangChain applications. LangSmith transforms debugging from guesswork into systematic problem solving by automatically tracing every step of your workflows, tracking performance metrics, and capturing errors for analysis. What are we trying to accomplish? We aim to give you complete visibility into your AI applications. By the end of this session, you will understand how to enable automatic tracing through environment configuration and add custom metadata to enrich trace information. You'll build performance monitors that track timing, tokens, and costs across workflow runs. You'll implement error tracking with automatic classification and targeted solutions, create feedback collection systems that measure user satisfaction, and integrate all monitoring components into a unified dashboard for production observability. So let's go ahead and get into the lesson. So can someone read through this overview?
LangSmith is LangChain's observability platform that transforms debugging from guesswork into systematic problem solving. Instead of adding print statements and hoping logs contain useful information, LangSmith automatically traces every step of your LLM workflows, capturing inputs, outputs, performance metrics, and errors. Today, you'll learn how to enable tracing, interpret traces for debugging, monitor performance, and track errors effectively.
All right, thank you, Nick. Can someone go over why LangSmith matters?
Without observability, debugging production, AI applications feels like flying blind. You can't see what's happening inside your workflows. Example, imagine your AI customer service agent works perfectly in testing, but in production, users complain it's slow, gives inconsistent answers, and sometimes fails completely. Without LangSmith, you're guessing which component failed. With LangSmith, you'll see the exact trace, identify the failure point, and deploy targeted fixes and confidence. With confidence, sorry. Approach, print statements. The description will be manual logging throughout code, and the limitation is cluttered, incomplete, hard to correlate. With the approach of basic logging, the description is capturing inputs and outputs, and its limitation is no timing, no intermediate states. With the LangSmith approach, the description will be an automatic tracing of everything, and its limitation requires LangSmith account.
So we are actually going to be just touching on LangSmith, creating a LangSmith account. It will be optional. The code in the lab will still run, but I'll just show you guys how to set it up quickly and just how to get your API key as well. All right, can someone go through core LangSmith concepts?
LangSmith provides visibility into your LLM applications through automatic tracing and structured logging. How LangSmith works. Number one, tracing captures every step of your LLM workflows. Number two, logging records all inputs, outputs, and intermediate states. Number three, metrics track latency, token usage, and cost. Number four, error tracking identifies and diagnoses failures. And number five, evaluation enables testing and validation. As an example, think of LangSmith like dev tools for AI applications. Just as browser dev tools show network requests and JavaScript execution, LangSmith shows LLM calls, tool usage, and workflow execution, all in a structured and searchable interface.
All right, thank you. So setting up tracing, enable LangSmith by setting up environment variables. So to set up LangSmith, you're going to have within your environment or .env file, you're going to be setting up these keys. So this right here, LangChain tracing v2, you're going to set it to true just to say, hey, I want to enable tracing within my system. And then LangChain project, you choose the project name. You're just That's going to be within your .env so that you can separate everything within the LangSmith UI on the browser and just keep things more organized. And then you're also going to have your LangChain API key so that it is able to connect. What gets traced? LangSmith automatically captures comprehensive information about your workflows. So we have 5 different categories. We have LLM calls, tool usage, chain execution, errors, and performance. So within LLM calls, what's captured, your prompts, responses, model settings, use cases, debugging prompt issues. For tool usage, the tool selection is captured, inputs are captured, outputs are captured. Use case is verifying the tool behavior. For chain execution, you have step sequence and intermediate states, and it will check the trace workflow flow. For errors, what's captured is the failure points and error messages, and you will get diagnose issues. And for the performance category, you're capturing execution time and token counts to optimize speed and cost. So traces provide a structured view of every step in your workflow, making the debugging systematic rather than random. So this is an example trace structure. So if you look, so we have our trace ID, the start time, end time, and then the total duration of the run, whether it was successful or a failure. And then you have the individual steps. So for example, your research node, analysis node, and then your summary node. And each one also has its duration that it took to run, the amount of tokens used, and the cost for each one. And you have your total tokens that's cumulative from all these different steps, as well as the total cost. So adding custom metadata, it enriches traces with custom metadata for easier debugging. So you can just add extra metrics to your metadata like query length. Example, adding metadata like query length, timestamps, and step identifiers makes it easy to correlate failures with specific inputs or processing conditions. And then we have performance monitoring, track execution time, token usage, and costs to identify bottlenecks and optimize your workflows. So building a performance monitor, this all pretty much just tracks performance metrics for optimization. So for performance metrics, we have 4 different metrics over here. We have latency, token usage, cost, error rate. For latency, it measures time per step. Token usage measures input and output tokens. Cost measures API charges, and error rate measures failed calls and total. Identifying bottlenecks, it just provides recommendations based on the metrics. So say your average time was greater than 10 seconds. It will give you the solution. So use faster model or optimize prompts depending on what it finds. If you used an average token of more than 2,000, your solution will be reduce prompt length or implement chunking, and it will return those recommendations. What I'm thinking here too is like you make another LLM call to say, hey, what can I do to fix this problem instead of just hard coding it. Example, if your research step averages 12 seconds and uses 3,000 tokens, you might switch to a faster model, shorten the prompt, or break the request into smaller chunks. Error tracking, systematic error tracking helps you identify patterns, diagnose issues, and implement targeted fixes. So what are some common error types? Timeout, rate limits, token limits, empty responses, and parsing errors. What's a cause for timeout? Slow API response. The solution is to increase the timeout or use an async so that it can run while the system is still going. For a rate limit, the cause can be too many requests, so you can implement backoff or throttling. Token limit, if the prompt is too long, you can chunk the input or compress the prompt. Empty response, you can, so the cause would be model returns nothing. Solution, you can retry that logic or specify a clearer prompt. For parsing error, a cause would be invalid output format. Solution, better formatting instructions. So building an error tracker. So this just tracks and analyzes error patterns, and it will log those errors with context into a list, and also it will keep track of your error counts in a dictionary. And we also have a method here that will analyze those errors. And then error-aware workflow steps is just a wrapper that tracks errors for any step. So it'll wrap uh, it'll wrap your node so that it specifically knows where that error came from. So for example, if 80% of your errors are rate limit issues, the solution is clear. Implement exponential backoff, error classification turns vague, something failed into actionable insights. Logging and feedback, capture detailed logs and user feedback to continuously improve your AI applications. And then collecting user feedback, it just submits user feedback for a trace. For a feedback loop, so we have 4 steps: collect, analyze, and improve and validate. For collect, the action is gather user ratings and comments. Outcome is raw feedback data. Analyze, action is identify patterns and low scores. Outcome is you'll get the problem areas. For improve, action would be refine prompts or workflows. Outcome would be better responses. For validate, action is check if improvements work, and outcome would be measure progress. So best practices for tracing setup: enable early, use projects, add metadata, and set retention. For enable early description, turn on tracing from development start so that it can keep track of everything. Use projects that organizes traces by environment, feature. Add metadata, include user IDs, versions, context, and set retention. For configure data retention policies. Performance monitoring, set baselines, monitor trends, create alerts, track costs. So set baselines, establish normal performance levels. Monitor trends, watch for gradual degradation. Create alerts, notify on threshold violations, and track costs, monitor API spending. Error handling, for practices, classify errors, add context, implement retries, and document fixes. So for classify errors, categorize by type for analysis, add context, include input state and step info, implement retries, add retry logic for transient failures, and document fixes for recording solutions for common issues. Privacy and security, for best practices, scrub PII, so remove sensitive data before logging, control access, limit who can view traces, use metadata, reference IDs instead of raw data, audit regularly, review log data periodically. So summary for the components, we have tracing, metadata, performance monitoring, error tracking, feedback, and logging. In the lab, you'll see that we'll have pretty much different classes for all these different components that have different methods within them. So the purpose of tracing is capture every workflow step, and the key benefit is complete visibility. For the metadata component, you enrich the traces with context for easier debugging. For performance monitoring, it tracks timing and costs and identifies bottlenecks. Error tracking classifies and logs failures. Key benefit is pattern detection, and feedback is you collect user ratings for continuous improvement, and logging records all interactions for audit and analysis. LangSmith transforms LLM debugging from guesswork into systematic analysis, giving you the visibility needed to build reliable, optimized, production-ready AI applications. I know that was a lot. Any questions? I will add on to that. So I do a lot of monitoring at work, and there's always new things added to the list of what we have to monitor. Most of the time, I don't even know what I'm looking at, but the key skill to have is to be able to research and to get a better understanding and be able to have an answer. So, lab debugging and monitoring LangSmith. This lab teaches you to implement observability in your LangChain applications using LangSmith. You learn how to enable automatic tracing, add custom metadata for debugging, build performance monitors, track errors systematically, and collect feedback for continuous improvement. So objectives: by completing this lab, you will set up a LangSmith project with tracing enabled, create traced workflows that capture execution details, add custom metadata to enrich trace information, build a performance monitor to track timing and costs, implement error tracking with classification, create a feedback collection system, test all monitoring components together, and analyze traces to identify optimization opportunities. So let's go ahead and get started with the lab. Let me just set this up on my other screen real quick.
You said you do this a lot at work. What kind of projects are you tracking?
So I work for a marketing agency, and the client I'm working for is the U.S. Army. So we work, I pretty much monitor the email campaigns that go out to leads, and I just monitor everything in the system from our Lambdas to our S3 buckets, and uh, if I see anything wrong, then I'll create an incident report, root cause analysis, and pass it up. Is usually how it goes.
Thank you.
Originally, we were doing things manually, but you know, you always got to try to think of a better way to do things as well. So whether that's like creating a script or any ways that you can improve your process. That's why I'm also big on trying to teach you guys the automation and so that you guys really get that down as well.
Thanks, I appreciate it.
Mhm. Okay. Sorry, guys. I was sick in the middle of the week this week. I think I'm starting to get it back. All right, let's make a directory called lab. All right, let's cd into lab. Let's just go ahead and install our dependencies. You guys should already have them installed as well. Now let's create our .env file. and open up our VS Code. So we're going to want to add our AWS profile. The profile I use is default. Yours might be different. And then we're going to want to add that LangChain tracing v2 and set it to true so that this system is going to have tracing within it. We want to specify our LangChain project, and we're just naming it LangSmith Lab. So now let's create our LangSmith Lab Python file. And add our imports and setup. So we have our imports, we have Bedrock, and then LangGraph, as well as type dictionary and time. We load our environment variables, and then we're just again taking in those keys from our .env file, setting them up. We create our Bedrock client and then initialize our LLM. So for part one, just like this morning, we are creating our state. This time we have query inside, result, execution time, step count, token estimate, cost estimate, error, and trace metadata. And then we just have comments on the side that kind of specifies what they do. So we're going to add our helper functions for our state management. So we're going to add a function that creates our traced state. So it creates the initial state with tracing metadata. So this is just pretty much creating a state out of this blueprint or formula, and then passing in that query to actually have something inside and setting everything else to default. So either 0 or blank. And then we also added an estimate tokens function and estimate cost function. So tokens just just estimate the tokens used and then the cost that occurred. Let's go ahead and add a test function. It's just test that our state got created. Let's see what we get back. So the only thing that got modified was our query with that test query input. Everything else should still remain the same as what we set up in that create traced state. So everything is set to default or 0. So for part two, our next step, we're actually creating our nodes. So just like this morning, we have our research node, analysis node, and our summary node. So the difference is we add metadata to it. So we start off with our print statement, and then we just set a variable to start time for our start time. And then we just capture all the different metadata for this specific step in this node. So whenever you see step, think of it as node, because whenever it runs through that node, that will increase your step count. Within this step metadata, we specify the name of this specific step. So our step name is research. It's kind of like the labeling that we did earlier. We have our start time that we set up over here, and then the input length of our query. So now we try invoking our LLM with our prompt, and we get our result. We then calculate our metrics. So we take the current time and subtract the start time from it to get that duration. And then we call our estimate tokens function and our estimate cost function. This part right here, it just updates our step metadata that we had up here. So duration, we'll have the duration tokens, cost, output length, and then status will be success. If there's an error, it will still have the duration, but the status will be failed, and then it'll give us our error. And we're just updating our metadata. So we're creating a variable called trace metadata, and then state trace metadata. Go ahead and Command F that. So that's actually held within that initial state we had. So it's just updating our state. And we return, just like earlier, we take our state and just change the keys that we currently that are listed below. So for result, we'll get the new result, execution time. It will update with a new time, step count, token estimate, cost estimate, and so on and so forth. And it's the same thing with the traced analysis node and the traced summary node. Let's go ahead and add a test function. Let's run it. See what we get back. So notice how we are getting this authentication field for API that for this URL. This right here is just saying that we don't have the LangSmith API set up in our .env file. That's why it's returning that, but the code still ran and everything is still good. So now let me show you guys LangSmith. Let me give you guys the link to that as well. I just posted it on chat. So just go ahead and create an account. I used GitHub to create my account. It was the fastest. After you create your account, it's going to give you like a bunch of screens to go through. I skipped most of them except for one where it'll say get started with tracing. If somebody can actually share their screen too, uh, that would be optimal. I can just walk you guys through it. Yeah. Okay. So from here, you can go to get started with tracing. Yep. Just go ahead and click on that, and then generate your API key. And you can create a new one after this, Nick. I'll show you how to delete this specific one. So yeah, that's how you can create uh, your API key.
And then we stick that in our env
Yep,
and
yep,
reference it in the code so it wouldn't fail all those API calls.
yep, exactly. So yep, and then the other way to generate a new API key, if you on the top left, you see the two arrows facing to the right. If you click on that, if you go to bottom left corner on workspace 1, or actually click out of that box real quick, go to settings, yep. And then yeah, this where you can delete it and then create your API.
Now I can regenerate it without you guys seeing it. Okay.
Yep.
So that's it. Generate an API key, stick it in the env, reference it in the code, and that's all we need to get going.
Yeah, yeah.
Okay.
So all this is pretty much doing is collecting all that tracing data and pushing it up to LangSmith's cloud. Okay, let me share my screen again. Okay, can you guys see my VS Code? Okay. All right. For the API, forgot what I put in here for the actual key.
LangChain underscore API underscore key, all caps.
Okay, yep. Thank you. Then I actually have to create a new API key because I didn't copy it down. So give me one sec. And yeah, I don't care if you guys see my API key. It's just for the lab. I'll delete it later. So now if we rerun that code, the error we were seeing earlier should be gone. So if we look at this test, it's giving us the duration and tokens for each node. Let's actually go back to the file itself. So we're printing out some statements and then creating our state with this query benefits of renewable energy. And then we're testing each node. So for research node, we're calling that node function and passing in our state. and we're just getting the duration and formatting it, as well as the tokens, and the same for all these other nodes as well. And as you can see in the bottom, it gives us the total execution, uh, total tokens, and total cost. So we're good to go. Any questions? Right. So now let's go to part 3. We're actually creating our performance monitoring class. And inside we have different methods. We have a record run, get summary, get step analysis, and then we print out our report. So this just initializes our runs. So we have a list. It's the list of all the completed runs, and then we have a dictionary of our step metrics. So it's going to be a dictionary of metrics grouped by the step name. So over here in our record run, we're just recording metrics from a completed workflow run. We have our example run data, and we're just appending that to our run. And then we're collecting all those metrics and consolidating it into one place. So this part right here is says group the metrics by step name. This right here, it says create a bucket for this step if it's the first time seeing it. This section right here, it just adds the steps metrics to the bucket. And then this part right here just tracks the success and failures. This method is just getting the performance summary. And then, so this get summary method just calculates overall statistics. There's a lot more code, so I'm just going to start for each method, just go through an overall idea, go through the overall idea of what they're doing, and then so that you guys have more hands-on time to go through it later and go at your own pace. So this method get step analysis just analyzes each step individually. So for either research, analysis, or summary, so you can compare their performance. And then this print report method just formats and displays all the data from get summary and get step analysis so that you can actually have a consolidated place where it shows everything. This get recommendations that I just added, uh, it's a method that automatically detects problems by comparing metrics against thresholds, and it will then suggest fixes. This print recommendations just formats and displays the recommendations from the get recommendations in a readable way. So let's go ahead and add a test function, see what we get output. Just let it do its thing. It should print out a report at the end. And we'll go through this test performance code as well after we see what we get output. So in this test, it shows us what's happening as it goes on. So it's testing each of the different nodes. And then we actually get printed out a performance report with the overall metrics. So there was only a total run of 3. So that's for each step. We have an average execution time, average tokens per run, average cost per run, and then the error rate. Below that, we have the per step analysis. So for research, the average duration was 3.95 seconds. Duration range was from 3.54 seconds to 4.44 seconds. Average tokens, 1,000. And then success rate, 100%. And we have the same thing for the 2 other nodes for analysis and summary. And then we have optimization recommendations right below it. So for the research node, we see that there was a high token usage. Let's actually go through our test code real quick. So we print out some statements. We call our performance monitor class, or we set the performance monitor class within it. And then we create our workflow, adding node, adding the edges, and then setting entry point and compiling. We have our test queries. And for each one, we're printing out what we're testing. We're creating a state with that query. And then we're finally invoking that workflow or app. And then recording the run into our class and passing in our final state. So after we do that, we actually print the report and print the recommendations. So let's go back to our print recommendations. So there's a specific part I'm looking for. Or actually, I think it's under get recommendations. Yep. All right, so over here for our research node, let's go look back at our output. We see that we had an average tokens of 1,045. If we look within our get recommendations method, if the tokens we used are greater than 1,000, then we want to append this to our recommendations. And the suggestion, so the solution would be reduce prompt length or implement chunking, as we can see right over here. And it also gives us the current amount of tokens. Does that make sense? And then it does the same thing for the other nodes. So for analysis, we see there's high latency. So let's look up here. So we had an average of 5.99 seconds. we see over here, if it's greater than 5 seconds, then we want to do the same thing. And it gives us our suggestion. Consider using a faster model or shorter prompts. We also notice for the analysis node, there's high token usage. So we get that same solution from down here. And same thing for our summary node. Any questions? All right, let's continue. Now we're creating an error tracking class. So we have different methods within this class. So this class is for tracking and analyzing errors and workflows. So we have different error types right here. And then just like the previous class we made, we have the errors that get stored in a list, and then the error counts that get stored in a dictionary. And this is going to be so the reason why this is in a dictionary is because it splits everything up into it's each individual node. So uh, it'll have the research, summary, and analysis in different objects, and as well as how many errors they each have. So for our methods, we have classify error. It just classifies the error types based on message. We have a log error method, logs an error with context. We have a get summary. It just gets the error summary. And then we have get solutions. It gets solutions for logged error types. So as you can see here, for example, token limit, implement text chunking, shorten prompts, use summarization. And then we have a print report method. It just prints the error report. As you can see with the two different classes, like a key thing is to be able to print out and see all these different data and metrics, because that can really help you with debugging and implementing solutions. So let's again go through what each of these methods do. So the classify error, it reads an error type and figures out what type it is. The log error records an error with metadata attached to it. Get summary returns statistics about those logged errors. Get solutions returns only the solutions for errors you've actually encountered. So if you didn't encounter a specific error, then it's not gonna get a solution for it. And then print report just displays the formatted error report. We're also going to add a function, which is a create error aware node. And this just, I think I mentioned it earlier, it just wraps any node function with automatic error tracking so that when an error is logged, you know which node caused it. Let's go ahead and add a test function. All right, so it's saying testing the error tracker. and it gives us some simulated errors. We have a timeout, rate limit, token limit, parsing, unknown, and it just gives us the cause of it. So for timeout, connection timeout after 30 seconds, and then rate limit exceeded, try again later, token limit, it exceeded 4096. Parsing, it failed to parse the JSON, and then there's an unknown error. If we look at the error report, we have 5 total errors, 1, 2, 3, 4, 5. And we have the errors by type with percentage, so 20% each. And then we have our suggested solutions that we have within our get solutions method. So for timeout, increase timeout settings, use async processing, and break into smaller requests. For rate limit, has that implement exponential backoff, add request throttling, and upgrade API tier, and so on for the other errors. Let's actually look at the unknown. It says review error logs, add more specific error handling, and contact support if persistent. Now we're implementing a feedback collector class. So it just collects and analyzes user feedback. And then we have our feedback entries that will get stored in a list. And we have different methods within it. So we have submit feedback, submits feedback for a trace. So it records a user's rating for a specific workflow run. We have get summary. So it calculates statistics from all feedback. Get insights generates human readable takeaways from data. Print report displays a formatted report with a visual bar chart. And hopefully you guys can start seeing like a pattern between all these different classes. It kind of follows the same format, but it is slightly a little bit different depending on what it's used for. But they all have a print report or get summary function. Or not function, but method. We added a generate trace ID. It just generates a unique trace ID. And then we added a function, create trace run. It creates a trace run with the ID. So this function right here, it just creates a unique ID string. And then this function right here creates a new workflow state and assigns it a new unique ID. Just add a test function. I didn't even gotta call it. I was like, why is it only giving me 2 lines? So if we look at our output, we are testing the feedback system. So we're submitting some feedbacks. So these are different ones. So the first trace is excellent response, very helpful, got a rating of 5. And then last one is great work. And yeah, we just have different feedbacks that we're submitting. And then we get into our feedback report. And this is just from that print report method. And here's that chart that it was talking about. It calculates how many feedbacks there are. So we had 8, and then it takes the average score from all 8 of those and gives us a visualization. It also gives us more info with insights. So the moderate satisfaction, we got a score of 3.6 average, 25% of responses rated negatively, 1 to 2 stars, and then 7 feedback entries include comments. So it's just analyzing those reviews. Move on to part 6. We have a workflow monitor class. So it's integrated monitoring for LangChain workflows. We have we initialize our performance class, error tracker class, feedback collector class, and then create a dictionary for our traces. So we have different methods. We have our start trace. This just starts a new traced run. So it begins tracking a new workflow. We have a complete trace method. So it completes a traced run and records metrics. It marks a run as done and records all metrics. We have an add feedback method. It adds feedback for the trace. And then we print out our dashboard. Let's add a test function to see what we get as an output. Any questions so far? I know there's a lot of information, but as long as you guys are getting familiarity with it, so you'll have it in place and you guys can also do more research on your own afterwards. So let's look at this code real quick. So we have some print statements. We set our workflow monitor class to a variable. We create our workflow, adding nodes, adding the connections, setting the entry point, and compiling. We have our test queries. And then we have our, let's see what we get down here. This part right here is just query score comment, test query, start trace. So it just starts the trace and runs the workflows and goes through the workflows and adds the feedback pretty much. So this part right here. And then we're calling our print dashboard method. So actually go to it. So down here in our output, for an overview, we see a total trace of 3. 3 were completed, no errors logged, and 3 feedback entries. Performance, we have an average execution time, average tokens, and average cost, and then feedback, average score, and a positive rate of 67%. So this part right here is just the summary stats for each of these, or for the overview. And then performance highlights. We're just getting the average execution time, tokens, and cost. And then feedback highlights, just printing out our average score and positive rate. So part 7 is going to be the last part. So we have a function called analyze trace. So it analyzes a single trace for issues. So it examines one completed run and flags any problems. We have print trace analysis. So it just prints the trace analysis. And then let's go ahead and add our test function. So within our test function, we print out statements. We have our workflow, and then we run and analyze. So we create our state with this query. We get that trace ID, or we generate that trace ID, and then we set it within our metadata. And then we finally invoke our final state. And we analyze that final state and print out the analysis of it. So what we get output is the research node with a query that gets sent to the analysis and then summary. And then we have our trace analysis ID, our query, execution time, tokens, cost, and any issues found. So high tokens, token usage 4,000 exceeds the 3,000 threshold. And we ran through all the tests, but let's go ahead and run it. Why not? Any questions? That's pretty much the end of the lab. Any thoughts, comments, concerns? You guys like monitoring?
Only because it helps me do what I want to do, not for monitoring's sake.
Yeah. Just staring at the screen.
Way nicer than just putting a bunch of print statements in there and hoping for the best. That's for sure. Using their actual built-in monitoring tools. 'Cause that's how, I think everyone first starts in Python. You just add print statements everywhere and hope for the best.
Mhm. Yeah, exactly. And that can be a lot to go through. You're going jumping back and forth between functions. And then hopefully this lab also kind of gives you guys ideas of what you can implement for your own projects and how to make it better so that you do less work. You'll probably put in more work in the beginning, but there's that trade-off. All right. If there's no other questions, comments, or concerns, go ahead and take a break and then just go ahead and get started with the challenge. You can keep on, if you didn't finish the challenge from this morning, keep on working on that. You can keep on uh, implementing those stretch goals as well, or you can jump straight to this challenge over here. Really depends on what you're more interested in, I think. And yeah, just go from there. All right, let me stop recording.